don't have any slides for you, so don't be disappointed, because 30 minutes are not enough to demonstrate how to build multi-region applications. So that's why I decided, why don't we skip the slides? I'll show you how to deploy multi-region applications and optimize them for low latency access. And then, if you find this useful, you can always go to the internet and search for the content that was created by people that are much more brilliant than I am, right? I don't want to repeat anybody. So the topic for today is too far too furious, multi-region cloud applications. So my name is Denis Magda. I've been working with distributed databases, systems, and applications for the last 9 years, I guess. Before that, I was building Java, JVM, and JDK at Oracle and Sun Microsystems. But eventually, I joined the brutal world of databases, and I remained there ever since. But that's a very joyful ride. So the agenda for today is follows. First, we need to answer a question: why would we even decide and think to build a multi-region application? What are the reasons? And then we will jump straight to our sample application. We're not going to build from scratch that application. Does it make sense? We have a prototype of a simple application for a pizza company. Like you take your phone, you order a pizza, that pizza is being baked for you, and then you enjoy this pizza, right? So we will create we already have some simple microservice. And then finally, we will wrap up. Good? Sounds reasonable? So why multi-region applications? And speaking about multi-region applications, when would you create the one? A multi-region application is an app that is deployed across several distant locations. And those distant locations can be your private data centers or several availability zones in the cloud or multiple regions in the cloud. And why would you do this? First is high availability. Why so that? Because take several regions. You have West region in the United States, you have East region. It can happen that one of those regions goes down. If the region goes down, it takes down all of your application instances and your database nodes that are being deployed there. And you have that question, are you ready to be out for the time while that region is being recovered, or you want to get back fast as soon as possible? And that's like one of the reasons. You want to build multi-region applications if you want to be available and tolerate even major incidents that happen that affect an entire region in the cloud. The second reason is low latency, and that's our primary topic for today. Let's say that you have customers in San Francisco, New York, and London, and Sydney, and Mumbai, and they use your application like pizza company. And you want them to have the same experience. You want them just to open this application, you want the app to be responsive, you want the app to not to hang, right, not to freeze. And again, to do that, you also need to build an app in such a way that the latency is comparable for all of your clients regardless of their physical location. And which means that in the multi-region context, you need to think about global low latency, okay? And final reason is data regulatory requirements. So sometimes, yeah, you have this wonderful app that you created, but if you operate in the European Union or let's say in India, then you need to comply with some data regulatory requirements. The user data, some of the personal data has to be stored in those locations. You have to do that. And how do you do that? By creating a multi-region application that spans multiple geographies, multiple countries. So next, why multi-region applications? We answered this one, right? Yeah, I just documented this in the wrong place, but not a big deal. Now, let's talk about our sample application for the pizza company, how we will be moving forward. First, we have our developer prototype that I will show you. And this prototype is going to be running on my laptop. And then we will take this prototype and we will deploy it to the cloud, to a public cloud environment. I'm using Google Cloud by default. You are free to use AWS, Azure, or whatever you like more. And that first instance of the application will coincide with the grand opening of our pizza location in New York City. And as you will see, when you're talking about global and multi-region applications in relation to the low latency, you need to figure out how to store your data, because it's extremely easy to deploy an application instance in any region that you choose, and you can have multiple instances. But if your application instance is deployed in New York City, but your data stays and lives in San Francisco, then the latency will be high, and that's not going to be a fast application. So that's why we need to figure out how to deploy your database. And then our application is going to expand to locations in Berlin and Sydney. So we think this way. The company keeps growing, and it wants to sell the same pizza in Germany and in Australia. Why not? But we want to have the same experience. And by looking at these stages of this company, we'll experiment with several deployment and design patterns for those multi-region applications. Primarily, it will all depend on how you deploy your database and how you exactly store your data close to your application instances. All right. Let's save this agenda for now. And let's start with the developer prototype. It should be somewhere under the downloads folder, sample applications, Pizza Spring Cloud. So this application comes with two microservices. The first microservice is kitchen controller. You take your mobile phone or you go to a website, you order pizza, and this order goes into the system. And this is what the kitchen controller does. It accepts your order, and hopefully then the chef will bake this pizza for you. So, and how do you interact with this microservice? Through REST APIs. We are going to send simple REST APIs to this microservice to schedule another pizza for our kitchen. The second microservice is called Tracker. And the Tracker is also a customer-facing microservice. What it does, once your pizza is already in the queue, you want to check the status, whether it's still being baked or it's pending or it's being delivered to you. Okay? So two simple microservices. You have a gateway, and what this gateway does, it basically going to intercept. We are going to send all of those REST requests to this gateway, and if the path URL in this gateway talks to kitchen, we will redirect this request to the kitchen microservice. Otherwise, we will redirect the request to the Tracker microservice. Make sense? So now let's deploy the first instance of this application, Docker, compose up, just to show you how those APIs look like. Yeah, this is a Java application, but it doesn't matter what's your primary language here. It can be any. So the point is that the design patterns remain the same, whether you use Python, Scala, Java, or C++ when you build a multi-region app. So looks like it's ready. So let me jump back to my terminal. That's a ping. So one of these HTTP requests is going to, it says service unavailable, which means that my microservice is still registering with the gateway. So for some reason it takes time in my Docker environment to register all the microservices, but that's my problem. Anyway, so it responded. As a database right now, I'm using PostgreSQL. It also runs on my local laptop. Now let's put the first order. So let's say that we want to put the first order, the first pizza for New York. Let's put the second. And so here's what's interesting. Yeah, we have this confirmation that the order was placed for New York, the status is ordered, and this is the latency. This is the latency between my backend, my application instance, this microservice, and my database. And my database, Docker container ls is, somewhere, this Postgres instance. And when we will be deploying this application to the cloud, we will be keeping an eye on this specific latency because we want to minimize this latency and we want to make this latency comparable for all of the client locations where our pizza service operates. Okay? Sounds good. This is how we post the pizza, and you remember that we have their Tracker microservice, the one that lets us check the status. So let's say that I want to check the status for the order number 1. Yep, so once it's warmed up, No, not the post. I want to do the get. Yeah, it also comes, yeah, that's the status. We're not going to change the status, and that's the latency between the application instance and the database. And here, as you can see, always the total latency, but the total latency is subjective. It means it depends on how powerful your machine that runs the application backend. So it will change. The more cores you have, the lower the latency will be. Now, going to the cloud. Let's say that the developer prototype is ready. It's easy to follow. And now we decided to open the first pizza location in New York City. And here is my production environment. What I'm going to use, I have this virtual machine in the United States East Coast. And also, we are looking into the future. I have 2 virtual machines in Europe, West 3 region. It's in Frankfurt in Germany. And I have another machine in Australia, close to Sydney, because I'm going to sell this pizza in Berlin, in New York, and in Sydney. And I want to make the same latency. I want to provide the same user experience. Now, the connection, I already have this connection. So this is the USA. That's my instance in the East Coast. That's in Germany, and this one in Australia. Imagine right now that we have the first customer who decides to buy this pizza from us. The customer takes mobile phone, goes to our mobile application, and that mobile application connects to this instance, right? That instance runs my pizza backend. And eventually what we do, this application instance puts the first order into the database. Yeah, by the way, let me first clean the database. I need to start this application instance. I'm using a special script. I will just show you what's happening internally. While this is happening, yeah, let me also start the same application instance. I will start the same application instance in Germany and Australia so that we don't waste a lot of the time. Because it will take time to register my microservices with the gateway. All right, looks like we are ready. In Europe, the application instance is running. Now let's just clean the database. Yeah, it says that the service is still being registered with the gateway. Speaking about the database, on my local laptop I was using PostgreSQL, which makes sense. When I'm deploying across multiple regions, I want to have PostgreSQL that can run across multiple regions. I need to have distributed PostgreSQL. As a monolithic database, Postgres is not distributed by default, but we have Yuga by DB. Yuga by DB makes Postgres distributed. It's built on the PostgreSQL source code, which means that I take the same application that was written for Postgres, and I deploy it across multiple regions, and I can deploy Yuga by DB across multiple regions. So effectively, that's happening. My first cluster that is being used right now, it runs across 3 regions: United States East 4, East 1, and Central. Which means that, and this is a transactional database, meaning that my application right now is connected to this node in the East. We can easily check it. Database address, US East 4. This is the IP address of the database the app is connected to. But when I will be putting orders into the system, this order needs to be replicated, because the replication factor is 3, meaning that if any of these regions goes down, nothing is happening from the availability standpoint. I'm not losing any data. There are no any data inconsistencies because the database uses Raft consensus protocol to replicate changes consistently across your deployment environment for the database. So that's why it will take, from the write latency perspective, the latency will be higher because the database will be replicating all those orders across 3 regions in the United States, Central and East. Now let's see at the real latencies. Okay. We are putting the first order into the system. Let's put the second. Let's put the third, etc. So the latency, the total latency is like 200 milliseconds. I'm running on a low-end machines. Just don't pay too much attention to this total latency. It's adjustable. But the database latency is 19 milliseconds. And this is a good one, considering that your database runs across 3 regions: US East 1, US East 4, and Central. It's quite a large area in the United States. And this configuration allowed us, we picked this configuration because we want to survive outages in the region. If any of these regions goes down, my application keeps running because the database is available. However, let's take a look at the read latency. Let's say that I want to check their order status for the first pizza. Yeah, I'm warming up my connection pools to the database, and their latency is 4 milliseconds, because this application instance is connected to this the closest database node in the United States, East one, close to New York, and the latency is just 4 milliseconds, which is good for me. I have this multi-region application running, and I can have as many application instances running in the United States East. Make sense? Now, our baseline is 18 milliseconds for writes, because we are replicating across multiple regions, and 4 milliseconds for reads. It's fast application. Now, let's take a look at what's happening in Germany. Let's say that we decided to sell these pizzas to our friends in Berlin. And what's the latency right now? Because this application instance is also connected to the same database node in the United States. Let's try to put the first order. I'm putting, let's say, order number 10, and I'm putting this order for Berlin. And while we are doing this, let me also do the same for Australia. I want to put an order for Australia in Sydney. Someone from Sydney ordered the pizza. All right, let's put a few orders. So here is right now, take a look at Berlin. The latency is 191 milliseconds. It's 10 times longer. Where is this one? This one, it was around 18 milliseconds. Anyway, why this happening? Because the application instance needs to send this request through the land under the Atlantic Ocean before it gets to the database node in the United States. That's why you have this much higher latency. If you take a look at the latency from Sydney, it's even 2 times worse than for those who live in Germany, because you either need to travel through the Pacific Ocean or you need to travel through the continents through Atlantic Ocean until you get to the United States. And this is the problem. And this is the problem that we want to tackle. Because let's say that the companies wants to expand successfully in Europe and Australia, but the latency is really bad. And right now I'm just sending, a few requests, like 1 request a minute. But what happens if I'm going to generate, let's say, hundreds of requests every second? That's going to be a big deal. One of the options is, and the most trivial one is, let's say, in the beginning when you scale, most of the time what we do as users, before we buy any pizza, we surf, we browse, right? We take this application, we take a look at the pizza catalog, or probably we will be building our custom pizza, which means that we are sending read requests to our database. And the first natural choice might be, all right, let's optimize reads. There are many ways to optimize read requests. One of them is just to deploy read replica nodes of your database to the locations of your clients. And let's do this. So we already have this primary cluster of the database nodes in the United States that keeps consistent copy of the data and survives outages. But for my clients in Germany and Sydney, I want to use read replicas. So let me restart their microservice instances. They will be reconnecting to different database nodes. I will show you in a moment what those nodes are. So here is this cluster, the main cluster. And down below, I have 2 replica nodes. One of the replica nodes in Australia, and the second one is in Frankfurt. So when it comes to replica nodes, the changes from the primary database cluster are sent asynchronously to the replica nodes, meaning that when you will be reading from the replica, you might not see the latest data. But what's important, as long as this is a transactional database, even if you don't see the latest data, the data is always consistent. So you will not have any inconsistencies like, all right, like if you're updating multiple tables within a single transaction, then all of those multiple updates will be visible to you at once on the replica node. It will not be like one table A is updated, but changes for table B are not delivered yet. That's not happening. So let's see how replica nodes are helping us. So here is right now, just to double check, yes, this application instance is connected to replica in Europe. This one is to Australia. How about we send, no, not the send. Let's just get the order status for order number 10. And here is order, what was that, order number 20. We don't need the location field. Hold on. Sorry, I messed up a little bit. And here, order ID. Yeah, the first time when you connect through the replica node, what's happening? Why do we have this delay? The database, the application instance opens connection pools, database connection pools through the replica, and the replica needs to load some metadata from the primary database cluster. So which means that you're waiting while that metadata from the primary database cluster is loaded. So that's why you usually warm up your connection pools when you restart your application instance. So if you repeat this several times, let's see the latency, 3 milliseconds. Looks comparable, right, to the United States. This is how fast it will take to get the status to complete the read operation in Berlin. You have the same latency. If you do the same for Sydney, let's run this a few times. It's also 4 milliseconds. So the first job is done. You have what we have. Let's do a quick summary. You have multiple application instances running in the United States, Berlin, and Sydney for your pizza company. And right now we achieved the same low latency for read requests. So whenever your customer opens your mobile application web front-end, starts searching through the pizza catalog, the latency will be comparable, no matter where a customer lives. But the second problem, let's say that your company is getting bigger, and right now they want to streamline all those operations, which means that they want to minimize the latency for write requests as well. They want write requests to be as fast as possible across all of those locations. And read replica nodes are not helpful here. Why? Because read replica node will basically forward all those requests to the primary database that is in the United States. That will take a lot of the time. However, for that, we are going to use another database cluster called GeoPartition. So let me restart my application instances one last time, and then I will show you the latencies, and we will take a look at their database cluster. Okay. Geo, this one connects to Frankfurt. And this one connects to Sydney. So what this GeoPartition cluster does, it's here. I have 9 database nodes, and that's a single stretch cluster, one database instance that stores data in the United States, Europe, and Sydney. And in every region, so here is just for the sake of experiment, I decided just in every country, I decided to select one region, but you can have as many regions as you like in every country. But within every region we use 3 availability zones. So with this configuration, in every country, you will be able to tolerate zone level outage. And the replication factor is still 3, meaning that if you put an pizza order in Sydney, then 3 copies of this order will be stored across 3 availability zones. That's for the availability, from the availability standpoint. And then I have, let's say, database nodes in Frankfurt, Virginia, in the United States. From the table standpoint, like what this cluster is capable of, it will be taking your orders, and it will decide, the database will store this order in one of the locations. If you're ordering pizza from New York, then this order will be stored in New York. if you're ordering pizza in Sydney, this order will be stored in Sydney, not in Europe. And that's a trick. This is how you can minimize this latency. So the database does this automatically for you. From the application standpoint, what you do in your table, in your pizza order table, you already have this column, city name. And then you can create so-called partitions in Postgres. And let's say this pizza order USA partition is stored in the United States. This one is in Europe. When your application does this insert, let me show you here, kitchen. You're still doing this insert into the pizza order. You provide the city name location. That's all you do. Internally, the database decides where the order is going to live. All right, so let's quickly check the latencies. First, let me just delete everything from that geopartition database instance. So like this delete operation, what's also interesting here, every application instance is connected to its own database nodes. This one is connected to the nodes in the West. This one is connected to the nodes in Australia. And this one is connected to the nodes in the United States. But I can use this single database connection to run global requests. It's like if I am ready to take that higher latency, because probably I need to delete everything, or I'm traveling to Europe and I need to order pizza for my family that lives in New York, from the application standpoint, you don't need to do anything. Just your application is connected to these database nodes, and if this database node decides, all right, this order actually needs to be transferred to the United States, the database will do this. You don't need to do that. All right, let's do the latency test. Okay, we are putting, again, the first order for New York. Let's do 1, 2, 3, caches were warmed up. So the latency this time is like 8 milliseconds, 7 milliseconds. It's slower because right now I'm using a single region for the United States, and the data is replicated across 3 availability zones. It's obviously faster. So you can do this configuration. 7 milliseconds for the United States. How about Germany? How about customers from Berlin? Let's say that we are ordering from Berlin. And let's do the same for Australia. So here is the same. In geopartition cluster, there is a concept of the primary cluster, like there is some primary metadata. And this primary metadata is stored in the United States, which means that when you open your database connections from the application the first time, this metadata also needs to be transferred. That's why you need to warm up your connection pools. But once it's warmed up, let's start putting all those orders for Berlin. Does it look familiar? 7 milliseconds from Berlin, 7 milliseconds from the United States. The same latency, right? The same application, just a little bit different database configuration. So let's repeat this exercise for those who live in Australia. 7 milliseconds. Sometimes 9 milliseconds, all right. So it's just the same single-digit low latency, millisecond latency. And if you want to check the status, let's do get request. Let's read the status. Order number 1 for New York. Order number 2. It's like 5 milliseconds, 3 milliseconds. Okay. So let's do here. We want to read order number 10 for Berlin. And that's another microservice. And here is again, right now, we are opening this connection pool from that second tracker microservice. And it's loading metadata from United States. It happens only once when you restarted your application and you need to warm up your caches. But once it's loaded, you will see that the reads are going to be fast all the times. So yeah, 3 milliseconds for Berlin. Yeah, it takes much more time to load this to Australia from the United States, but prohibitively long time. What's happening? All right, yeah, we have a minute left, and hopefully this query will end sooner. Let's do this once again. Yeah, the metadata was loaded. It's the same time. So generally, this is how you can build multi-region applications that scale by designing your application from top to the down. Select cloud regions that you think suit the best your user locations. Then provision your application instances in all of those cloud regions and decide about your database deployment. You have multiple database deployment options. It can be just single cluster in one region across multiple availability zones if your all primary users, let's say, live in San Francisco. If you operate across the United States, you can provision across several regions and you can optimize reads. If you have customers globally and you want to optimize just reads, you can use read replicas. Or if you want to have low latency for both read and write requests across distant locations, then you have geo-partition cluster. So keep this in mind. That's going to be an excellent kind of reference book for you when you will be building multi-region applications across locations. Thanks for coming and have fun. So for the questions, where should we head?